Lesson: Selecting the right tools for AI operations. Selecting the right tools for AI operations is fundamental to optimizing the performance and effectiveness of artificial intelligence systems in any organizational environment. The variety of tools available today can be overwhelming, yet each plays a critical role in different stages of AI deployment, from data preprocessing to model training, deployment, monitoring, and maintenance. This lesson will delve deeply into actionable insights and practical tools that enable professionals to make informed decisions, address real-world challenges, and enhance their proficiency in AI operations. An essential first step in AI operations is data preprocessing, which involves cleaning, transforming, and organizing raw data before feeding it into machine learning models. Effective data preprocessing ensures the quality and reliability of the data, which directly impacts the performance of AI models. Tools such as Apache Spark and Pandas are invaluable for this task. Apache Spark's ability to handle large datasets efficiently makes it ideal for enterprises dealing with massive amounts of data. Its distributed computing capabilities allow for parallel data processing, significantly speeding up the preprocessing phase. On the other hand, Pandas, a Python-based library, provides high-performance data manipulation capabilities for smaller datasets. Its intuitive data structures enable quick data cleaning and transformation, making it a favorite among data scientists and analysts. Once the data is preprocessed, the next critical step is model selection and training. This phase requires robust frameworks that can handle complex computations and provide flexibility in model building. TensorFlow and PyTorch are two widely recognized frameworks in this domain. TensorFlow, developed by Google Brain, offers comprehensive tools and libraries that facilitate the development and training of machine learning models. Its scalability and deployment capabilities make it suitable for both research and production environments. Conversely, PyTorch, developed by Facebook's AI Research Lab, is praised for its dynamic computation graph, which allows for more intuitive model building and debugging. This flexibility is particularly beneficial in research settings where experimentation is frequent. Real-world challenges in AI operations often involve deploying models in production environments where they can deliver actionable insights. This task requires tools that ensure seamless integration and scalability. Docker and Kubernetes are two pivotal technologies in this space. Docker enables the encapsulation of applications and their dependencies into containers, ensuring consistent performance across different computing environments. Kubernetes, an open-source container orchestration platform, takes this a step further by automating the deployment, scaling, and management of containerized applications. Together, Docker and Kubernetes provide a robust solution for deploying AI models at scale, ensuring they run reliably in any environment. Monitoring and maintaining AI models in production is another critical component of AI operations. This phase is crucial to ensure models continue to perform accurately and efficiently over time. Prometheus and Grafana are popular tools used for monitoring AI systems. Prometheus, a time series database, collects metrics from configured targets at specified intervals, enabling real-time monitoring of applications. Its alerting capabilities help identify issues before they escalate, ensuring timely intervention. Grafana complements Prometheus by providing interactive visualization of the collected data, making it easier for teams to understand the health and performance of their AI systems. A practical example of these tools in action can be seen in the case of a financial services company that implemented an AI-powered fraud detection system. The company used Apache Spark for data preprocessing, handling millions of daily transactions, to identify patterns indicative of fraudulent activity. PyTorch was chosen for model training due to its flexibility in experimenting with different neural network architectures. Docker and Kubernetes facilitated the deployment of the models, ensuring they could scale with the company's growing transaction volume. Prometheus and Grafana were used to monitor the system, allowing the company to maintain high accuracy rates and promptly address any performance issues. In selecting the right tools for AI operations, it is essential to consider factors such as the scale of data, the complexity of models, the computational resources available, and the specific requirements of the deployment environment. Additionally, staying informed about the latest developments and best practices in AI tools and platforms is crucial. Engaging with the AI community through forums, conferences, and online courses can provide valuable insights and keep professionals updated on emerging trends and technologies. Statistics from industry reports highlight the growing importance of AI operations and the impact of selecting the right tools. According to a 2021 report by Deloitte, organizations that effectively leverage AI tools and platforms see a 25% improvement in operational efficiency and a 20% increase in revenue generation. These figures underscore the significant return on investment that can be achieved by adopting the right tools and practices in AI operations. In conclusion, selecting the right tools for AI operations involves a strategic approach that takes into account the specific needs and challenges of the organization. By leveraging powerful data preprocessing tools like Apache Spark and Pandas, robust model training frameworks like TensorFlow and PyTorch, scalable deployment solutions like Docker and Kubernetes, and comprehensive monitoring tools like Prometheus and Grafana, professionals can enhance their AI operations and drive meaningful outcomes. Continuous learning and adaptation to new tools and technologies are imperative in this dynamic field, ensuring that AI systems remain efficient, reliable, and effective in delivering insights and value.